This looks to be, I hope, a pretty good haul. I found this gnarled old birch tree for free on Marketplace in the wetter western part of the state. The saw I used to buck this tree into manageable section, well, it's in disrepair, neglected and forgotten. It sat for years waiting to return to the earth in the form of rust, or more hopefully, a renovation and return to usefulness. I'd like to give this saw the restoration it deserves and tell its story. I live in an old logging town and found this saw for sale locally for a mere $40. What is it? It's a 54-inch one-man crosscut saw with a perforated lance pattern of teeth. Last used half a century ago by a local logger, it was used to buck the massive felled conifers of Central Oregon. Using the saw was exhausting, but at least it was comfortable in hand and didn't leave any blisters or hot spots. It's far from perfect though. The handle is fastened to the saw by rusty bolts, tensioned by sharp square nuts. This lowest bolt isn't sunk into much meat, and the spine of the saw protrudes above the handle. All this leads me to believe this handle is a replacement. In order to give this saw the new lease on life it deserves, I'd like to carve a new hardwood handle. Then attach it with proper saw nuts, ones that sit flush and won't put me at risk of shearing the flesh of my hands. I'll add the saw to the workshop as a foundational piece of kit for green woodworking, and will proudly display the saw on the workshop wall, not only as interesting functional art, but also as part of Ben's rich history and its beginnings as a logging town. I'm excited to add my voice to that conversation. I've found a piece of local bastone walnut to carve the handle from. Bastone walnut is a hybrid between Oregon's native Claro walnut and the English walnut that was planted here by settlers. I started this handle using power tools for the sake of speed and efficiency. Power tools are what I know. They're what I was taught to use. But I've decided to broaden my skill set on this project and will, for the first time, use hand-stitched rasps and files to tease out the complex curves and contrasting sharp lines of the tote. The rasp allows me a level of refinement that router bits never could, as these complex curves must flow dynamically from one to the next. All in all, for my first foray with hand tools, I'm satisfied with the handle I've crafted. All it needs now is a set of vintage Simonds saw nuts. The brass and the Simonds banner both look stunning up against the tortured grain of the bastone walnut. The only clue I have regarding the provenance of the saw is this faint maker's mark. Note the parallel lines here under letters that spell Simonds. That version of the Simonds maker's mark only shows up in the 1904 catalog. The only one of those saws with a perforated lance pattern is the Simonds number 222. Now, in order for the saw to be as efficient as possible, we need to remove the rust from the saw plate. This will decrease friction and make it easier to cut. Unfortunately, a few light passes of the sanding block was enough to disappear what remained of the 1904 maker's mark. And so I designed a counterfeit and engraved it back into the sole of the steel. A light sanding, and now it's a secret revealed in the right light. Re-engraving the maker's mark was the right choice. But like everything else in this project, it was an experiment. I'm learning as I go, and though I shouldn't have been surprised, adding localized heat to one side of the blade over a 5-hour engraving process warped the blade badly. Thankfully, straightening the saw blade is part of the workflow Warren Miller describes in his Crosscut Saw Manual. What follows, the hammer and anvil straightening, the filing, hammer setting and raker swaging, is me following the recipe Miller wrote in his 1977 manual. Links for all the information will be below. Let's now turn our attention to the cutting edge. This giant hook at the butt end, see how it sticks down past the cutters? It should be in line, which means this saw has been sharpened many, many times over the course of its life, shortening the teeth. The cutters are even shorter in the center of the blade, where most wear happens. They're so short that the cross bridges are going to keep me from being able to set the teeth. So I'm cutting them out. While I'm at it, I'm going to reprofile the entire geometry of the cutting edge so that the saw can function efficiently again. Grinding the gullets elongates the teeth, giving the saw renewed life. To hold the saw firmly, I built a proper crosscut vise. The vise sandwiches the saw blade between a pair of profiled 2x10s, squeezed together with eye bolts. Now I can clean up the gullet profiles with rat tail and chainsaw files, smoothing these curves. Next, I built a magnetic jig to help me dial in the proper angle of the cutter teeth. There are 3 important angles: rake, fleam, and slope. The ends of the jig are cut to 35 degrees. This angle, the fleam, is a good balance between sharpness of the teeth and durability. A removable piece of plywood cut to 15 degrees is screwed to the ends of the jig. This angle affords a consistent slope across the teeth. As for rake, or the amount the file is twisted in hand, well, I'm freehanding that. This allows me flexibility to point the cutters symmetrically. Up one side of the saw, then down the other. Slowly, we creep up on perfection. Let's pause for a moment and talk about how a crosscut saw actually cuts. Simply put, the teeth of the saw, the cutters, act as a series of knives, half this way, half that way, that score and sever the wood fibers in a set of parallel lines. A second type of tooth, the raker, then releases the wood in between the cuts by acting like a small chisel. In order for the saw to cut efficiently, each component of the cutting edge must be dialed in precisely. Each cutter tip must be in line with all the others. We use a combination tool along with a captive file to joint the cutting edge to ensure each of those tips are in line. There are many vintage combination tools on the market. I'm using the Simonds 340. Once the cutting edge is jointed, we can point up the cutter teeth and begin working the rakers. I start by using an 8-inch 3-square file to shape the raker profile. The goal is to sharpen the raker tooth, then turn it with a hammer, a process called swedging, to form a proper angle of attack so that it can lift the severed fibers. I filed to a sharp point, realizing later this was a mistake. Better to leave a small flat spot, turn the tooth, then refine it with a file from the underside. This helps protect the raker teeth from an errant hammer blow. Ask me how I know. What we're looking for is a 30 to 40 degree cutting angle on the raker tips, and for those raker tips to hover 12 thousandths of an inch below the cutter teeth. This ensures the rakers don't try to remove any unsevered fibers. I maintain a consistent height by filing them using a precisely set combination tool. Lastly, we need to keep the saw from binding within the kerf. We do that by setting the tips of the cutter teeth wider than the thickness of the saw. To ensure uniformity, we use a tool called a spider. The spider has one leg 12 thousandths of an inch shorter than the other. Then, with hammer and handheld anvil, we strike the beveled side of the cutters, bending them until the tip touches the shorter leg of the spider. If all tips are set to this point, the teeth will work in unison and will work to sever the same line of fibers. None will drag. And those are the processes to sharpening a saw. It's a tremendous amount of work. This seemingly simple tool, designed to roughly portion up massive timbers, turns out it isn't simple at all. When I bought the saw, I naively assumed all I had to do was touch up the bevels and voila, the saw would be sharp, and if sharp, that it would cut well. My intuition was terribly, horribly wrong. In truth, this saw was engineered to have a subtle, precise, refined edge geometry that, quite honestly, is challenging to understand, challenging to restore, and challenging to maintain. Is it any wonder that after a century of hard use, abuse, neglect, and well-intentioned butchery, that the vast majority of these saws and other vintage tools like them have fallen into such a state of disrepair that I would be ashamed to display them on this workshop's walls the way they were found in the wild? Because to an educated eye, they barely resemble the tools they were designed to be. And so I repeated all the processes. Rejointed the edge, re-swaged the rakers, repointed the cutters, all to dial in the geometry as perfectly as my skill and knowledge would allow me. Old saws like these, they're part of our heritage. They tamed the frontier that was the American West and birthed the logging town I live in. This saw in particular, a 1904 Simonds Model 222, is now officially an essential foundational tool in my green woodworking toolbox. It has a functional future again. To those ends, I dub this saw Birchbane. A fitting name, I believe. There's only one thing left to do now, to test the saw, to see if Birchbane sings. Join me next time where we'll process the gnarled old birch that gave name to this saw. The plan is to split it and carve it into bowls, kuksa, and hopefully blanks that will eventually be turned into a matching set of spalted birch bench flames. See you then.